While away down southern Ontario, I never had a nickel or a dime to save.
Let's begin this lecture series on environmentally friendly production practices by defining what an environmentally friendly production practice is. It's any management decision, G, E, or M, that's done not with the view of increasing yields or increasing revenue or profit, but with the goal of resolving or minimizing environmental problems associated with agricultural production or cropping systems. Now, what these environmental problems are, we're going to get to, but essentially any management decision that's done for those reasons and not to increase yield or revenue is environmentally friendly. Now, some will argue that in the long term, if you do environmentally friendly production practices, in the long term, in the long run, you're going to end up increasing yields or increasing revenue. I'm sure in the cover crop section of this lecture, we're going to learn about that. My own humble opinion, having looked at the evidence, really with no dog or horse in that race, is that this is a bit overblown, that the synergy between environmentally friendly production practices and higher yields and higher revenue in the long term, I think that's a bit overblown, but that's my humble opinion, and I'll show you some evidence. But ultimately, this is up for debate. So the environmental problems associated with modern agricultural production or industrial agriculture are a consequence of its massive success. Some people, some critics of industrial agriculture, modern ag, will say, well, we have these environmental problems. That means that modern agriculture itself is flawed, but that is the wrong way to look at it. Modern agriculture has been so successful in terms of innovating, adopting new management practices, and producing food that success has led to environmental problems. If you ask your grandparents or your great-grandparents if they've ever went hungry, they would be able to tell you about episodes in their lives when they did go hungry. Maybe your grandparent, like mine, once got a single orange on their birthday. That was their birthday present, a single orange. So in the past 100 years, we don't have people going hungry. We don't have people, at least in Canada, getting an orange for their birthday. It's a little bit of a ridiculous present. We don't have presidential candidates like Herbert Hoover in 1928 promising people, I'm going to give you a chicken in every pot. We don't have ration cards in terms of we can buy as much butter and as much meat as we want in a grocery store. The worst that happens is that we can get hangry if we miss a meal or two. And this is all because of the massive success of modern agriculture. Now, what did I say again? That the problems associated with modern agriculture are due to its spectacular success. Here's a list of problems. Food waste. People talk about food waste as a problem. It's because food is cheap, right? If a head of broccoli is $2 or $3, it might go to waste. You might use half of it. You might not use it at all. If a head of broccoli costs $100, then you're going to use the whole thing. So we have cheap food, safe food, abundant food. That's exactly what we wanted in modern agriculture. Again, 120 years ago, there was people thought there was going to be mass starvation, and there was no mass starvation. Greenhouse gas emissions, land clearing. 120 years ago, there was no mechanization. Now we have mechanization. Okay, so we have tillage, we have tile drainage, we have land clearing. Land clearing obviously causes greenhouse gas emissions, converting, say, a forest to crop production. Livestock emissions. We have cheap feed. We have more efficient production systems. We have more livestock. People love to eat meat. So we have more livestock and we have more greenhouse gas emissions associated with livestock. We also have consumers who actually can afford meat. And that's because of their rising incomes. We don't have 50% of the population laboring on farms. Mechanization. We have nutrient pollution. Nitrous oxide emissions, a potent greenhouse gas we're going to talk about. We have phosphorus runoff into the Great Lakes. This is a problem I'm sure you're aware. This is a consequence of the massive success humanity's had in making plant nutrients available. Right? Look, cheap fertilizer, yes, it goes up and down in price based on market swings and whatnot, but there was no fertilizer around 300 years ago. You were using manure, you were using plant wastes. In the 19th century, farmers were applying mining waste like slag that had sulfur ammonium in it to crop fields. And so now we have widely available, strong distribution, cheap fertilizer. nutrient pollution. We have nitrous oxide emissions, a potent greenhouse gas from nitrogen fertilizer use. We have phosphorus runoff from agricultural fields into the Great Lakes. That's because of high rates of phosphorus being applied to agricultural land, so the soils are very rich in phosphorus. This is a consequence of cheap fertilizer, plant nutrients that are widely available, inexpensive. I mean, look, there's market prices, it goes up and down, but 300 years ago, there was no inorganic fertilizer, there was no urea, there was no triple superphosphate. And so we had a problem. The problem was a lack of plant nutrients. Now we have too much of it. Okay, this is, again, a consequence of success. This is a good problem to have from this perspective. So we have agriculture's massive, spectacular success at producing cheap, safe, and abundant food over the past 100 and 120 years on one hand, and we have the environmental problems, a consequence of this success on the other. So how do we not throw out the baby with the bathwater? How do we keep safe food production that's cheap and abundant, and at the same time reconcile and reduce these environmental harms that, I just gave you some examples of, but there's many others. Well, people label this different ways. They call it regenerative agriculture, carbon farming, climate smart farming, agriculture. It used to be agriculture 4.0, now it's agriculture 5.0. Anyway, how do we solve this problem? Coming up with this lecture, I came across a really nice recent article published by two professors at the University of Guelph, Malcolm Campbell and Evan Fraser, two experts on food security. And they have this agriculture 5.0, reconciling production with planetary health. And they say we have 4 pillars, 4 things we need to change about modern agricultural production to get to this a newer system that has cheap, abundant food and is environmentally healthy, what they say protects planetary health. Okay, so what are these 4 pillars? The first pillar is sustainable intensification. By that, they really mean producing more food on less land and with fewer inputs. Now, what farmer would not agree with that, right? Your land, very high capital cost in most of the rich world, most of the developed world. So if you can produce more food with fewer inputs on that land, well, that's just higher revenues. Okay, that's increasing your margin. So that's absolutely a good thing from the farmer perspective. From what you could say a planetary health perspective, well, if you're not clearing land because you're producing more food on available land, well, that's just good in terms of protecting local habitat, increasing biodiversity. If you're not land clearing and converting, say, forest to agricultural land, you're not releasing greenhouse gases and carbon dioxide into the atmosphere, so there's a win there. So step 1, we need more food, less land, fewer inputs. Now, they say later, how do we get there? They say 2 things. We need biotechnology, and we need more precision agriculture, or what they call digital agriculture. So more biotechnology means things like more newer varieties, better varieties of crops, but also biotechnology of microbes that can assist those crops. And an example of this would be microbes that are genetically engineered to infect corn roots and synthesize nitrogen, produce nitrogen for that corn, as opposed to using inorganic fertilizer. And there's companies working on that. By digital agriculture, I mean, I'm sure you know what they're talking about with precision ag. That's just site-specific management, using resources or crop inputs more judiciously when they're needed. Okay, so that's first pillar of agriculture 5.0. Second pillar is, and this is specific to the developing world, that digital agriculture is not a panacea, or it's not a silver bullet. So biotechnology, digital agriculture, these new tools, they're going to be very powerful in the rich world. But in terms of global agriculture, most farmers globally are located in the developing world. They're not very well off. They often own 2 hectares of land or less. That's like something like 5 acres or less of land. And these are not folks that need a drone. They don't even have a combine, so there's no point putting a yield monitor on a non-existent combine. These are folks who have very different needs. And so the idea is you need to think through what technologies are going to be the right fit for the right kinds of farmers. And farmers in the developing world, probably not so much technology in terms of digital agriculture, right? Just getting mechanization started up in these areas is going to be a big win for them. Okay, we don't need to talk about mechanization in a country like Canada. Okay. The third pillar of Agriculture 5.0 is to tackle food waste and food distribution. Now, in the developed world, in the rich countries, this is not so much an on-farm problem as it is on other parts of the supply chain, be that grocery stores or restaurants or in people's homes. That's where most food waste occurs. In developing countries, it's a different story. Again, farmers that don't have proper storage facilities for grain storage, they don't have refrigeration, they don't even have electricity. So for these folks, you might harvest your rice, but if you're trying to store it as best you can, but it's hard to avoid spoilation, some rot. Same thing if you have an animal, a large animal like a pig or a cow, you're not going to eat the whole thing all at one time. How are you going to preserve your meat from that slaughtered animal? It's difficult to do, again, avoiding spoilation. When you don't have refrigeration, electricity, etc. Okay, fourth, what they argue Agriculture 5.0 requires a shift in dietary choices, or at least an understanding of the impact that dietary choices have on the planet. So in developed countries, what these authors and many others would argue is that we're eating too much animal-based products. We need to shift to a more plant-based diet, and if we do that, it's going to improve planetary health. The challenge with this, of course, is that a steak tastes really good, ice cream tastes really good, omelets taste really good. And so convincing people to shift to a plant-based diet is going to require either regulation, something like a tax. It's going to require maybe innovation on the private sector side, developing like cellular agriculture or meat substitutes or what you call plant-based meats or plant-based milks or plant-based egg products or whatever. If this happens, if human diets in the rich world shift towards more plant-based diets, then that's obviously going to have a huge impact on cropping systems. Those farms that have crop livestock integration, but even if cash crop farms, if most of that grain is being sold eventually for animal feed, well, if those animals aren't alive, then where's that grain going? Where's the market? So this is going to have, if successful, it would have a huge impact. Again, in developing countries, it's a different story. They probably need to eat more animal-based products. They need to eat more meat, more eggs, etc. Now, I have a fifth point to round out this Agriculture 5.0. This is my point, so this is not the opinion of the authors. But fifth point of Agriculture 5.0 is, at least in northern areas of the world where the climate is warming, is to take advantage of climate change, to take advantage in terms of designing cropping systems to better take advantage of the new climate, this new E factor that we're going to be experiencing in the next 50 years. Now, what in a nutshell, what's going to happen? We're going to have longer growing seasons with higher temperatures. We're going to have more rainfall in the growing season, but occurring in shorter, more intense bursts, like really heavy downpours. And we're going to have more solar radiation, what's called solar brightening. Now, this is not the sun getting brighter. It's just the fact that we have more radiation hitting the ground, hitting those crops, so we have more opportunity for photosynthesis. And that has to do with less cloud cover. So what do I mean by taking advantage of climate change? Well, here's one thing. You will have a longer growing season, but if springs are wetter, which they might be, well, how are you going to be able to get on the field in a timely manner? Right, so the temperature might be right to plant, but if it's too wet to get on that field, well, then you might not be able to take advantage of that growing season. Indeed, in very northern areas like Finland, which is much further north, and they're going to have much warmer growing season than what they currently have. This is a problem they're having, just field trafficability, getting on that field in a timely manner. So, adapting management to take advantage of these changes. So the bottom line here, the main takeaway is that if humanity is going to shift, the rich world is going to shift to Agriculture 5.0 or regenerative agriculture, or whatever, climate smart farming, whatever you want to call it, it's going to require, it's going to have a huge impact on cropping systems, because it's going to mean that management decisions are going to be based on more than just producing food, right? Again, going back to the definition of environmentally friendly production practices, management that is done specifically with reducing environmental impacts associated with agriculture as opposed to increasing yield or revenue. We're going to have to make, or I shouldn't say farmers will have to make more environmentally friendly management practices and adopt those environmentally friendly production systems. So what does that mean? It means something perhaps like farming to reduce carbon emissions and increase soil sequestration. So you're not necessarily producing food, but you're trying to farm carbon, sequester it, and reduce emissions. It might mean something like changing cropping systems to meet a new diet, right? Again, if people stop eating meat, I'm not predicting that this is going to happen. I'm not saying it's going to happen, but if people stop drinking milk or what have you, cropping systems will have to adapt. And they already have in the past. Okay, 100 years ago, 25% of the land area was cropped to oats because we had millions of horses. It was horse-based agriculture. We had a lot of horses involved in many industries. We did not have engines, or gas engines, I should say. But then the Model T happened, and now we don't have very many horses anymore, and the agricultural system adapted. Okay. It's also going to mean, again, changing, for example, fertilizer practices or herbicide application or pest management strategies, not to increase yield or to increase revenue, but to reduce environmental harms. And it's also going to mean increased technology adoption, innovation, collaboration between farmers and scientists, farmers who are willing to be entrepreneurs and try to test out new technologies, see what works on their farm, use digital agriculture to make, you could call, evidence or data-based decision making, adopting new technologies, etc.